Alright, kiddos, here goes part one of some additional practice questions that I'm strongly recommending. 23 ends up sort of involving some simultaneous equations with trig stuff, so we're not going to do that one. You don't have to know that, it's not on the AP test. Question 22, however, is legit. So it says, a football is kicked at ground level with a speed of 18 meters per second at an angle of 31 degrees to the horizontal, or with respect to the horizontal. How much later does it hit the ground? So how much later does it hit the ground? We're looking for time. I took 18 meters per second and 31 degrees, drew a little triangle. First things first, calculated horizontal velocity, horizontal component of velocity and vertical component of velocity. We're looking for the time in the air, and so our given information would be something like this. We know that, I'm going to slide this over, so the ball is going to do that, land on the ground. So we know that the position when it lands, meaning vertical position when it lands, is height of 0. We know its initial position, it's kicked from the ground, height of 0. We know because we're on Earth, the acceleration due to gravity, negative 9.8 meters per second squared. We know the initial velocity, and so this is initial velocity in the vertical direction, is the 9.2 whatever meters per second. And what we're interested in is how much later does it hit the ground, so we're interested in time. Okay, so given that information, given our vertical and horizontal components of velocity, we can set up an equation that looks like this. So I'm hoping you got that right. Time in air. Okay, so position once it lands on the ground, initial position starting from the ground, initial vertical velocity. Notice how horizontal component of velocity, we're not paying attention to it. Time in air, acceleration due to gravity, and like with a lot of these, we end up with t and a t squared. This is negative 4.9 t squared. So what I've done is factored out a t, and we end up with two answers, one of which is t equals 0, one of which is t equals 1.89. That's 0 seconds and 1.89 seconds. So it makes sense that 0 seconds is when the ball starts. Here's our football. When the ball starts on the ground, and 1.89 seconds is when it lands on the ground. So this is the answer we are looking for that the question's asking. Thanks.